So in raster scan displays, what happens? This suppose you have something like your controller is somewhere. What happens actually? Let me tell you. Suppose you are having your system. This is your processor. Let me keep CPU along with CPU. Let me keep display processor separately. Okay, there is a display processor. Now what this display processor will do, it will take your data, whatever from the CPU we have got some output. This is something that we have to process. This display processor will create the output, okay, and to keep it in a memory. This memory we are calling it as frame buffer. Okay, this is frame buffer. In this frame buffer, actually you are storing the intensity for each pixel. Okay, all in your monitor you have these many number of pixels. So accordingly, suppose this is your screen, so you are generating one matrix corresponding to your this thing, display. So corresponding to your monitor, you are having this frame buffer, where for each pixel, suppose you will have multiple pixels which can be seen in terms of rows and columns. The lines are not straight, let it be, but try to understand that. This is a disaster, no problem, let me try. So for each pixel you are having some intensity value, so which is processed by display processor and stored in frame buffer. So in frame buffer you are having this matrix, and accordingly this CRT will work. You will have a video controller in between. This frame buffer will be given to let me come back. Frame buffer will be given to video controller. Okay, this video controller will understand this frame buffer and accordingly generate the signals for these all the components of this CRT, maybe the electron beam to lighten up, and after that these anodes and deflectors to position it. So it will, what it will do, according to a particular pixel intensity, for this pixel, if at all we are generating, so if for a particular pixel when we are generating the output, for a pixel if we are generating the output, what we are going to do, we are actually going to see what is there in this position. If at all it is, suppose we are keeping zeros and ones, so for zeros and ones, what it means, at the position where it is 1, it should be illuminated, otherwise it should not be illuminated, right? So in this way, what happens, wherever it is illuminating, we can see the output. So now here what happens, this is the way this matrix can be printed as an image to the display. Here the main thing that we have to understand in raster scan devices is that how it prints, how it actually works. So what it does, it scans. It is a scan device, which means it scans. It starts from the starting. If at all it is your monitor device, so let me make it a bigger pen width, and if it starts from a position, it scans through this first line, means it scans here, means it scans the buffer, it scans through it, wherever it was 1, there it illuminates, and rest of it leaves on. It comes to an end, and then it again starts from the beginning. It comes back here and starts from here, the second line of pixels, and wherever it was 1, if at all, then it will again print here, means illuminate the phosphor, or otherwise it will not illuminate and go till end and again start from the beginning, and will keep doing this thing. So in the last, what will happen, the positions where it was 1, means intensity values, as the intensity values were kept, according to those the pattern that we were trying to generate can be generated on the display device. Okay, now when it reaches the end, what will happen, again it will start from the left corner here, scanning again from the beginning, whatever we have in the this frame buffer. Okay, and here we have to understand the refresh rate again. What is the refresh rate? That means it completes its one scan from the left corner to the right end, and it completes its one scan, that is called one scan, right? So if at all it is a 30 hertz system, it means in 1 second it has to complete this cycle 30 times. Okay, so this is simple raster scan device, where it will scan each line of the pixels, and those pixels which should be illuminated, there the electron beam will be forwarded and it will be illuminated, and accordingly the display will come on the screen. And since it should not have flicker, we keep at least 30 hertz, this means 30 frames per second. In between, if the frame is changing, it is possible. Now if you really have issue where you cannot maintain such kind of frequency, in that case one thing is done, where you go through the line, okay, sorry, the first line you scan, and after the first line you leave the second line, and you again scan the third line, you leave the fourth line and scan the fifth line. In this way you can achieve the desired achieve the double refresh rate, okay, and avoid the flicker if at all it is possible. So this was something about raster devices. One thing that we were not talked about is color display. Suppose in the last case it was zeros and ones, so where it was 0 it is not illuminating, and where it was 1 it was illuminating. Done. Now if you want to show colored images, in that case what you will have, at each pixel you should have intensity values. Okay, intensity values for red, green and blue, RGB, right? So here you see red is 0, green is 0 and blue is also 0, which is making up to black, and when all of it is 255, 255, 255, it is making up to white color. And the combination of these intensity values will make up different other colors, ranging to many colors. Suppose here it is 255, so it is ranging that many colors from 255 plus 255 to 255, right? If at all we were having only the options of zeros and 1 here, that red is present or not, in that case 2 into 2 into 2, only 8 colors would have been possible at any pixel. So depending on how large we can store at for one value at each pixel, that makes it how much colors it can represent. Suppose if at each pixel you are having 8 bit 8 bit 8 bit, which means 24 bit at each pixel, it will give you this much colors, which is 255 plus 255 plus 256 actually. So 256 plus 256 plus 256, right? Let me tell you, 2 to the power 8 into 2 to the power 8 into 2 to the power 8, which is giving you 2 to the power 24 these many colors you can represent for any pixel, if at all you are having just 8 bit. And if really you want more colors to show, you can definitely increase the number of bits for this for each of the channels. In that case you will have more number of colors here. Okay, so but this was the story of frame buffer. Now what with CRT? CRT was having only one electron gun, but now you will have these electron guns separately for R, G and B, where you will be able to show the color. Here this color can be shown through which can move through a shadow mask. Since it is in a triangular way it has been arranged, so it goes to a shadow mask, from where it again comes to the phosphorus coated screen, and it illuminates, and three of them coming together at same place makes a color. That is the thing. And not only shadow mask, other way is also inline, where these three are kept in a line, and the lines can come from there. In that case you will not need shadow mask, it can directly come to this position and illuminate the phosphorus, and it can definitely give a color. So these are the way how CRT monitor works, and we have also seen something about raster scan devices. Next what we have to see is random scan devices. We will see it in the next video. Thank you.